Hello everyone. In this video, I am going to explain remaining parts of or remaining pins of 8086 pin diagram. Now we know that this is the pin diagram of 8086, which is a 40 pin IC. On left side there are 20 pins, right side there are 20 pins, and these arrows mentioned out here indicates the direction of data flow. So this indicates that data flows from outside world to 8086, and this indicates that data is flowing from 8086 to outside world. Outside world means to the peripheral devices, maybe input output device or memory. Here it indicates that data flows on both direction. That means on these pins data flows on both directions. So all these pins indicated are already explained in the previous video, that is VCC, ground, address data multiplexed bus, then read bar, write bar, minimum slash maximum bar, ready, reset, etc. Now the next pin is DEN bar and data transmit slash receive bar. Now remember that whenever we connect memory or input output device to 8086, we never connect that peripheral device directly to 8086. We always connect a bus transceiver IC in between. That is 8286 octal bus transceiver IC between the memory and 8086, or between the input output device and 8086. What this bus transceiver IC is, it is nothing, it is just a buffer IC which does not change the data. Whatever you apply at the input, same you will find at the output. It just increase the current carrying capacity of wire. Now what happens whenever 8086 communicates with the memory? Let's take an example of, now like say we have connected memory to 8086 through bus transceiver. So whenever 8086 wants to communicate with the memory, either 8086 will transfer a data to the memory or it will receive a data from the memory. When 8086 transfers a data to the memory, it is said that it is write operation. It is write operation. It is similar to writing into the notebook. When we write into the notebook, data flows, information flows from our brain to notebook. So here 8086 functions like our brain and memory functions like our notebook, and hence in write operation data will flow from 8086 to memory. And what is read operation? When we read from the notebook or from the book, information flows from book to our brain. So in read operation, data will flow from memory to 8086. So read operation is a receive operation in which 8086 receives the information. And write operation is transmit operation, because 8086 is transmitting the information to the other device. So there are two pins on 8086, that is data transmit slash receive bar and DEN bar pin. What is DEN bar pin? DEN bar pin of 8086 is connected to OE bar pin of 8286 octal bus transceiver. This is data enable bar pin. It is used to enable the transceiver 8286. That means whenever it is active low, there is a bar, so it is active low. Whenever this pin transfers this logic 0 to 8286, this octal transceiver will get activated. That means it is used to switch on this device. Then what is data transmit slash receive bar pin? It decides the direction of data flow through the transceiver. It decides the direction of data flow means if 8086 is reading the memory, that means it is receiving the data, then this should be at 0, because receive is active low, then it should be 0. If 8086 is writing into the memory, writing is a transmit operation and transmit is active high in this pin, so for write operation this should be at logic 1. That means if 8086 is reading, this pin should be at logic 0, and if it is writing, it should be at logic 1. Let's take an example that 8086 wants to write into the memory. Suppose this is a 1 byte and 8086 wants to transmit this byte to this memory. That means 8086 wants to write. Write means transmit, and for transmit it should be 1. Now it is a write operation. So write bar pin should be at logic 0. So what happens? First it will transfer 0 to this ICA to activate 8286. Then it will transfer 1 on this pin which is connected to T, transmit pin of 8286, which indicates transmit. Logic 1 on this pin indicates transmit operation or write operation. So this pin will transfer logic 1 on this pin to 8286. Then it will transfer address where 8086 wants to write. Suppose 8086 wants to write 200 on this memory location, whose address is 20003. So it will transfer 2000 on, this is hex number, not 2000 decimal. So it will transfer 2000 on address data multiplexed bus, that is 80 to 8015, and it will transfer this 3 on pure address bus, that is A16 to A19. This we have already studied in the previous video in detail. After that, what will happen? Then it will transfer data on same bus, that means D0 to D15 data bus, which is address data multiplexed bus. So this was the function of DEN and DT slash R bar pin. Now next is, this is about interrupt. What is the meaning of interrupt? Let's take an example, a layman example. This is you and this is your friend. Suppose you want to write one assignment in which there are 7 questions, and your friend also wants to write assignment of some other subject. There are 5 questions. Now let's assume that you are very intelligent and capable of solving all the questions on your own. You are very efficient and you have solved question number 1, question number 2, question number 3, and question number 4. Now your friend also wants to solve this question, but he is not intelligent and he is not able to solve this question. So what happened in this case? This friend will give you a call on the mobile. So when he calls on the mobile, you will get disturbed, you will get interrupted. You are solving assignment, you are at question number 4. So your friend will give you a call on the mobile and he will interrupt you. Why he is interrupting you? He will ask you to solve this assignment for him. Why he will ask you to solve this assignment for him? Because he is not intelligent and he is not able to solve this assignment. But you are intelligent, you can solve this. So he will request you. If you think, okay, he is my good friend and I should write these questions for him, what you can do, you will tell him that, okay, I'm ready to solve. That means you will acknowledge him. Then what you will do, you will solve this question and give him back. After solving his question, what about you? You have to again come back to your assignment and complete your assignment by solving question number 5, 6, and 7. So what is this all about? It was all about your friend interrupting you while you were writing your own assignment. Now let's assume that there is 8086 microprocessor in place of you, who is very intelligent and has brain. And in place of your friend, there is another device. This device is not a processor and hence it is not capable of execution of program. 8086 is a processor, so he can execute a program, but this device is not processor and hence he cannot execute a program. Suppose this is main program of 8086 and these are instructions of 8086 program. Suppose it has executed instruction 1, 2, 3 and it is somewhere here at instruction 4. Now this device also wants to execute its own program. There are 5 instructions. Now it is not necessary that the instructions or program of device should be always smaller than this. It may be a bigger program also. What this program known as? This program is known as interrupt routine. So what this device will do, this will send request on INTR pin. This is interrupt pin. What is INTR pin? It is an interrupt request signal. The way your friend called you on the mobile phone or calls you on the mobile phone to interrupt you, there is a pin. 8086 is a digital device. Everything is in terms of sending and receiving logic 0 and logic 1. So this device will transfer logic 1 to 8086 as an interrupt. What is this INTR says? INTR says this device wants to get this program executed by 8086. So it is an interrupt request signal which is sampled during the last clock cycle of each instruction to determine the processor considered this as an interrupt. For processor, for 8086 processor, the signal coming on this, the logic 1 coming on this is considered as interrupt. Then what 8086 will do, first it will complete the execution of instruction 4 because it is currently executing instruction 4. It will complete the execution of instruction 4 and will send acknowledgement to this device by sending logic 0 on this pin. What is this pin? It is INTA bar. It is active low. That means it is active when it transfers 0. This is acknowledgement of the interrupt. That means the meaning sending 0 on this pin is 8086 is ready to execute this interrupt routine. 8086 is ready to accept the interrupt. What is INTR? It is interrupt acknowledgement pin. When microprocessor receives this signal, it acknowledges the interrupt. When microprocessor receives this interrupt, it will acknowledge the interrupt on interrupt acknowledgement pin by sending logic 0. Then what 8086 will do, it will transfer its control to this interrupt routine and it will start executing this program. This program is also in the memory, this program is also in the memory. Both the programs will be on the same memory but at different memory locations at different addresses. So what microprocessor does, it will switch and will jump to another memory location and will start fetching instructions of interrupt routine. Then it will execute instruction 1, 2, 3, 4, 5, and after execution of interrupt routine, again it will go back to its original program and then it will execute remaining instruction. So this is how 8086 behaves in case of interrupt. What is interrupt for? Interrupt is given by this interrupting device if this device wants to get this program executed. Why this device wants 8086 to execute this program? Because device is not a processor, it is a device. It cannot execute this program. But 8086 is processor, it can execute a program. So all these things or all these functions, what is this NMI? NMI stands for non-maskable interrupt. On 8086 there are two interrupt pins. This is INTR is known as simple interrupt and this is known as non-maskable interrupt. What is meaning of non-maskable interrupt? There are chances that if some irrelevant friend gives you a call and asks for solution of assignment, you may neglect him or you may avoid him or you may block him. But there are some friends which are at very high priority to whom you cannot neglect or you cannot avoid. So non-maskable interrupt is an interrupt which 8086 cannot avoid. That means if some other device send interrupt on this pin, 8086 cannot avoid that interrupt. It has to acknowledge and it has to execute the interrupt routine. But the interrupt arrived on a INTR pin, their 8086 may refuse or may neglect this interrupt. So this is the difference between INTR and NMI. Both are interrupts, but one is non-maskable, that means non-avoidable, and INTR is maskable. That means if 8086 thinks that I don't want to acknowledge, then he may not acknowledge. Now next pins are HOLD hold and HLDA hold acknowledgement pin. Both pins are used when 8086 operates in minimum mode. These pins are used during DMA access. What is meaning of DMA? DMA stands for direct memory access. What is meaning of direct memory access? Suppose let's assume a situation that in which this is device 1 and this is device 2, and there is a huge data that device 1 wants to transmit to device 2. When device 1 wants to transmit huge data to device 2, it is said that it is direct memory access. It is not sending it through 8086. It is not sending it through 8086, but it wants to transmit directly to device 2, and that's why name is DMA access, direct memory access. So for this purpose, what is the problem in this? In this, the problem is device 1 wants to transmit the data to device 2, but it has no data bus or address bus for doing so. So what is the solution over this? 8086 has address bus and data bus. So what device 1 can do? Device 1 can send a request of buses to 8086. The way, suppose we want to go to some picnic, and when we don't have buses, what we do, we hire the buses. The same is applicable here. Device 1 wants to transmit a data, it needs the buses which it doesn't have, but 8086 has buses. So what device 1 will do, it will send a request for buses on hold pin to 8086. It is active high, hold is active high, so device 1 will transfer hold logic 1 on hold pin of 8086. Let's assume that 8086, this is main program, 8086 is executing its main program. It has executed instruction 1, 2 and 3. Now in between, device 1 transferred this 1 on hold pin. Now what 8086 will do after receiving this 1, first it will complete the execution of this current instruction, that is instruction 3, and it will release the control of buses. Control of buses means control on data bus and address bus. And it will send acknowledgement. This is acknowledgement of hold. It will send acknowledgement of hold signal to device 1 by sending logic 1 on this pin. What this indicates? This indicates that okay, I have given the buses are available for use. I have given away the control on buses, and now buses are available for you for data transfer. When this device 1 receives logic 1 on this pin, it understands that okay, now buses are ready for use, and device 1 will take a control of bus. After taking a control of bus, it will transfer the data to another device, and after this it will send logic 0 on this pin, indicating that the hold operation, the data transfer is done, and now you can take the control of buses back. So this is how hold and HLDA pin are used by external devices for direct memory access. Now next is request slash grant pin. Same thing, but here now it is not device, but it is a processor. This is processor 2 and processor 3, and here it is 8086. That means when other processors are connected to 8086, it indicates that 8086 is operating in maximum mode. Now let's see what happens here. It is 8086. It is executing its main program that consists of 7 instructions. This is processor. This is also processor. It can execute its own program. This is program of processor 2 that is also consists of 7 instructions. Now this program and this program both are stored in the memory. The programs are always stored in the memory. So whenever 8086 wants to execute its program, it has to fetch every instruction, and then execution unit will execute that instruction. Similarly, if this processor wants to execute its program, it has to fetch this program from memory, and execute the instruction. But what is the problem here? Here 8086 has buses for sending the address and receiving the instruction before execution. But processor 2 doesn't have address and data bus. So what happens when processor 2 wants to execute an instruction, it has to borrow buses from 8086 microprocessor. So what happens? It will send a request for buses on request slash grant bar pin. RQ stands for request and slash grant bar pin. Both are active low. So these are request grant signals. These are used in maximum mode because multiple processors are connected. These are request grant signal used by other processor. Signal will be sent by other processor requesting the CPU. Requesting the CPU means requesting the 8086 to release the system bus. System bus means address bus and data bus. So what happens? Let's take an example that 8086 is currently executing its main program. In between, this processor 2 also wants to execute its instruction. So what this processor 2 will do? This processor 2 will transfer logic 0. Processor 2 will transfer logic 0 on request pin to 8086, requesting for the buses. When 8086 receives this logic 0 on this pin, 8086 understands that processor 2 needs the control of buses. So what 8086 does, it will first complete the execution of current instruction and it will release the control on buses and give away the control of buses to processor 2. Now it will send acknowledgement by sending logic 0 on grant bar pin. It is only single pin. It is only single pin. On the same pin, 8086 transfer logic 0 to processor 2. This indicates the grant of request. That means request granted. This indicates that buses are available for use. Then what processor 2 will do? Processor 2 will take the control of these buses and will start fetching instructions from the memory and will execute the instruction. As long as processor 2 is executing the instructions, fetching the instructions from the memory and executing the instruction, it will this test bar pin at logic 1. It will transfer this logic 1 on this pin to 8086. So this is active low as long as, remember, as long as the buses are with processor 2. As long as the buses are with processor 2 and processor 2 is using the buses for fetching the instruction and execution of instruction, it will keep this test bar pin at logic 1. What it indicates that buses are with me and you please don't try to use the buses. What it indicates, 1 on this pin indicates that processor 2 wants to tell 8086 that the control of buses are with me. I am using that buses for execution of this program and you better wait for buses. So as long as 8086 receives logic 1 on this pin, 8086 enters into wait state and it will not try to execute the program. As soon as processor 2 completes the execution of this program, it will transfer logic 0 on this pin and then 8086 will receive the control of buses and will start execution of its program. There is another pin, that is lock bar pin. This is also active low. Now what happens, suppose this is processor 3. Processor 3 is connected. What happens? Now this is processor 2. Let's assume a situation in which the control of buses is with processor 2. As long as control of buses is with processor 2, 8086 will transfer logic 0 on this pin to processor 3. What it indicates, when this signal is active, active means this is logic 0, it indicates to the other processor, that means this is third processor. It indicates to the other processor that not to ask the CPU to leave the system bus because 8086 doesn't have system bus with it. and that's why it will transfer logic 0 on this pin to third processor, so that processor 3 should not send request grant, because there are two pins in 8086. There are two request grant pin, and hence we can connect two processors to request grant pin through 8086. So lock is for when this signal is active, it indicates to the other processor not to ask CPU to leave the system. Now next pin is QS1 and QS0. These are pin number 24 and 25, which are used in minimum mode. Now these are queue status signals. That means it will tell us the status of queue. These signals provide the status of instruction queue. Now what are the conditions? Now it indicates if both pins are at logic 0, it indicates that no operation is taking place. If QS0 is 0 and QS1 is at one logic, then it indicates that first byte of opcode is to be fetched from the queue. If this is 1 and this is 0, it indicates that queue is empty, and if both are 1, it indicates that subsequent byte from the queue is to be fetched. So these are queue status pins. Now next pins are S0, S1 and S2 pins. That is pin number 26, 27 and 28. These pins are used when we use 8086 in maximum mode. Whenever we use 8086 in maximum mode, we have to connect IC 8288 to 8086. In maximum mode, this 8288, which is a bus controller IC, this bus controller IC generates control signals for 8086. Remember, when we use 8086 in maximum mode, we have to always connect this 8288 bus controller IC to 8086, and this bus controller IC generates control signals for 8086 based on status of these pins. So 8086 has 3 pins, and 8288 also has S0, S1, S2, and S0 is connected to S0, S1 to S1, and S2 to S2. Now, how this bus controller IC generates signals? Now, if all 3 pins are at logic 0, that means if 8086 transfers 000 on these pins to 8288, then this 8288 generates interrupt acknowledgement signal, that is INTA signal for 8086. If it is at 001, then it will generate input output read signal for 8086. If it is at 010, then it will generate input output write. For 100, it will generate opcode fetch signal for 8086. If it is 101, it will generate memory read, 110 memory write, and 111 is passive. So these are the signals generated by 8288 bus controller IC for 8086. When 8086 operates in maximum mode, and 8086 has to send appropriate status, appropriate signal on this pin based on what exactly 8086 wants to generate. That means if 8086 wants to generate memory read signal, it should send 101 on this pin. So this is how S0, S1 and S2 pins generates various signals by the use of 8288 bus controller IC. So I hope you understood the concept. If you have any problem, you can always ask. Thanks for watching.